Hello. Today we're going to go through the similarity proofs, which are pretty fun to do and pretty close to what we've been doing in the 2.0 level, just adding like a little bit of difficulty to that. And so our learning target at the top is 5.3.2, and this is similarity proofs. And we are going to use our 3 similarity shortcuts to be able to complete these proofs. So that's going to be our evidence to complete the proof. So remember, we have SSS, where we need 3 sets of proportional sides. We have SAS, which is where we need 2 sets of proportional sides and 1 set of congruent angles. And then we have AA, which is where we need 2 sets of congruent angles. So if you need to pause that to get everything down, I know I'm a fast writer, you can do that. But this is going to be the evidence that we're looking for to be able to complete each proof. We need one of these 3 things, and we need to prove this set of evidence. And so I'm going to go through a few proofs that are very typical things that you'll see so that you can identify the evidence on your own when you do proofs as well, because no 2 proofs are really exactly the same, but they have a very similar feel. So for the first example, just like with all proofs, you're going to be given some givens. So in this case, we have CD equals 3AC and CE equals 3BC. And we want to prove that triangle ABC is similar to triangle DEC. And then you're going to be given a picture of what's going on. So in this case, we have a picture that looks like this. And just do your best to sketch it. Does not need to be perfect. So again, pause the video whenever you need to make sure that you have all the information written down. So we're going to be doing some 2-column proofs for these. So I'm just going to make my 2 columns. And then we're going to have our statement and then our reasons on the right-hand side. And I'm going to number each of them so it's pretty easy to see. And remember, we always start with our givens. So I'm just going to rewrite the givens. And our reason is that they are given. And then I know I'm going to end with this similarity statement, but until we get there, we need to figure out what evidence we have and which shortcut we are going to use. So again, you're going to be looking at this and you're going to kind of identify what's the information that I know, what am I going to use, am I going to have 3 sides or 2 sides, what's going to help me in this situation. And so in this case, they give us information about sides CD and AC. They also give us information about sides CE and BC. And so automatically I know I have 2 sides from each of the triangles. And so I'm not going to use angle. I already have 2 sides, so either I need to find the 3rd side to do SSS or I need to find an angle. And hopefully we've done these problems enough to know that the angle is the easiest one to find. So we have our angle C is congruent to angle C. So let's actually write that down. Angle C is congruent to angle C. Oops, I wrote a 2 over here, but this is supposed to be a 1. Sorry. And the reason these are congruent is because they are vertical angles. Vertical angles is a very common reason, and you'll see some other commonalities of ones you want to remember, but those are vertical angles. I'm going to get rid of my picture because it's in my way. So the next thing is we want to do something with these sides. And basically what we're trying to find is we're trying to prove that the ratio of sides is the same. And this is almost there, but not quite. So kind of what we want is the ratio of CD over AC, or vice versa, like AC over CD. We want the ratio of this side to this side. And then we also want to do the same for BC and CE. We want the ratio. And so if I look at this statement, CD equals 3AC, I'm almost there. If I want CD over AC, I can get rid of AC by dividing on both sides. So divide both sides by AC. And now I have what I'm looking for, a side over a side. So I have CD over AC equals 3. And you want to do the exact same thing for the other statement that they give you, because you want to make sure that these numbers, these ratios, are exactly the same. That's the only way you can prove similarity, is if they are the same. So CE equals 3BC. Again, same step, we just want to divide both sides by BC. And we get CE over BC equals 3. And since these are the same, that is good news. That means I have 2 sets of proportional sides. So back up to my proof, item 3 are these statements. So CD over AC equals 3, and CE over BC equals 3. And all we did to get from the given to this is just divide. And so my reason is just division. I just used division. And so now you can kind of see, like, here I have an angle, and here I have my 2 sides. And so together I have SAS, so I am ready to end my proof. So 4 is that triangle ABC is similar to triangle DEC. And the reason is SAS. So there's our proof start to finish. Our givens, we found an angle using the picture, and then we found our proportional sides using these statements. And we got SAS. So let's do another one. So for this one, our given is that side PT is parallel to side RS, and we want to prove that triangle PQT is similar to triangle RQS. And we are given, again, something that looks like the previous one. And so we are going to start our proof with our given information. So number 1 is that PT is parallel to RS, and that was given. And I'm going to kind of like draw in my symbols for parallel, those little arrows. And so if we have parallel lines, we're going to use a lot of the angles that we did in first semester with parallel lines and a transversal. So it might be helpful to like extend these parallel lines out. So these are parallel to each other. And then just choose one of these sides to use as your transversal and just kind of extend that out. I like to do it with a dotted line. And now you can kind of see like we can look at alternate interior angles and we can look at alternate exterior angles or corresponding angles. All of those are fair game when we're trying to find congruent angles. So you're going to use a lot of those types of things when you are given something that's parallel. So I'm not given any side lengths. I'm not given any information about side lengths. So I know that I'm going to be using AA. Maybe just like you can make a little note to yourself, AA. And so I need to find two sets of angles, and it doesn't matter what two. I can find any two sets of angles. So I like to do, if I have vertical angles, I like to do those because I think they're very easy to see. So angle Q is congruent to angle Q, and that is because they are vertical angles. But now I'm going to have to use the parallel lines and the transversal to find another set of parallel lines, or congruent angles, sorry, another set of congruent angles. And you can see like angle P and angle R are alternate interior angles. So you can see that they're cut by that transversal, they're alternate interior angles, so we know that they are congruent. If you used this line as your transversal, you would use the exact same thing, but it would be S and T. So we can say angle P is congruent to angle R, and this is because they are alternate interior angles. Again, you could use any alternate interior that you find, any alternate exterior, or any corresponding to help you find those congruent angles. But now we have two. We have an angle here, we have an angle here, and that's all we need. So we're ready to end our proof. Triangle PQT, similar to triangle RQS, and this is by AA. And so I'm not going to do a full proof, but I just wanted to show you, like, remember that you could also use the reflexive property to find an angle. So anything with like a triangle inside of a triangle, you're probably going to use the reflexive property to say that n is congruent to n. But those are really all the things you're going to need. The vertical angles, the alternate interior, alternate exterior corresponding, and then those statements where we solved for the side length. That kind of encompasses all of the proofs. So it just takes practice, but this should give you a pretty good idea of the setup of these kinds of proofs for similarity.